Okay, before we get started on actually long dividing today with polynomials, just want to take you back and remind you of what we did when we were dealing with actual numbers in long division. It's been a long time, I bet. So 12 into the number 1,480. 1,480 goes in the box, 12 on the outside. You ask yourself, how many times does 12 go into 14? And you would say once, writing a 1 up there. Then you would actually take 1 times 12, get 12, put 12 down here. Now you thought subtract at the time, but I'm just going to have you think a little bit differently, like change the signs and add down. So that used to be a positive 12. I changed it to negative 12. Now I'm going to add 14 and negative 12 together and get 2. Bring the next term down, get 28, and then now start over, rinse, lather, repeat. What do I take 12 times to get 28? And that would be 2. And then 2 times 12 is 24. Write it down, change the signs, add down, get 4, bring down the 0. How many times does 12 go into 40? That would be 3. 3 times 12 is 36. Write it down, change the signs, add down, get 4. We would say 4 is the remainder, so we would put 4 on top of 12 that we divided by, but we know 4/12 reduces to 1/3. So 12 going into 1,480 is 123 1/3. Now that's just a reminder of what we knew back then. On the next slide here, we're going to use these skills of long division with polynomials. Okay, so we're going to use our long division skills now to long divide some polynomials. So we're going to take x minus 3 into 3x cubed plus 2x squared minus 4x plus 1. And the way we'll do that here is we'll ask ourselves, what do we take x times to get 3x cubed? And that would be 3x squared. And then we take 3x squared times x and get 3x cubed. And we take 3x squared times a negative 3 and get negative 9x squared. Now at this point we will subtract, but I would encourage you to think about this as change the signs and add down. So when we add 3x cubed to negative 3x cubed, we get 0x cubed. When you add 2x squared to 9x squared, you get 11x squared. We follow the pattern we used in that first example by bringing the next guy in line down and starting over. Now because that 0x cubed is not really there, I'm going to just at this point erase it, and I won't show that anymore. When that totals to nothing, I just won't show it. Okay, it kind of causes confusion if you do show it. So the next step is to ask yourself, what do you take times x to get 11x squared? And that would be 11x. So we're going to put a positive 11x up here. And now we reach out and we say, what is 11x times x, and then 11x times a negative 3. So it would be 11x squared and a minus 33x. Okay, and so then we will change the signs again and add down. 11x squared minus, or added to a negative 11x squared would be 0x squared, so I'm not going to write that. And a negative 4x plus 33x would be negative 20, actually positive 29x, excuse me, positive 29x. And then we bring the next one down. And we rinse, lather, repeat again, asking ourselves now, what would we take times x to get 29x? Okay, and that would be a positive 29. So 29 times x is indeed 29x. 29 times 3 is, and that would be a negative 3, so it would be a negative 87. And now we're going to do the same thing, change the signs and add together. 29x and a negative 29x is 0, and 1 and an 87 is 88. Since there's no more things to bring down, the 88 is the remainder. I kind of left that there in blue as to stand out, so that's the remainder. So we would go write the answer as 3x squared plus 11x plus 29, including 88. And then remember, when you do the remainder, it is put on top of what you divided by. So it's 88 over x minus 3. That is our long division of that polynomial. Actually, there is something special to know when performing long division on polynomials. Do you notice that in the problem here, we're missing a term where we don't have any x's. We jump from x squareds to just constants. And in here, we're missing a term because we jumped from x cubed to 4x. There was no x squared term. So the trick to getting started with these is to make sure that everything is present in both what you're dividing by and what you're dividing into. So I would first write this as x squared plus 0x minus 1 headed into x cubed plus 0x squared plus 4x minus 2, because you need to have those missing terms present, or things don't line up well when you do the long division, and then that causes great confusion. So let's start with this now. What do we take times x squared to get x cubed? Just simply x. Let's take x times x squared and get x cubed. Let's take x times 0x and get 0x squared. Let's take x times negative 1 and get negative x. And now we will simply change the signs of all those and realize x cubed minus x cubed is 0x cubed, 0x squared minus 0x squared is 0x squared, and 4x plus x is 5x. And so in this case, we would actually be done with long division because there is no way that I can multiply by x squared something to get 5x because I'm below the level of what I'm dividing by. Therefore, 5x minus 2 is actually called the remainder. So simply put, the answer is x and 5. Clean that up a little bit. And 5x minus 2 over x squared minus 1. Now notice when you write your answer, you don't have to include that. But you do have to include it when you do long division, these two terms, because otherwise things will not line up well and you'll be very confused. You'll be trying to subtract like x squareds from x cubes, or the exponents won't match, and that'll be problematic. So that is a very special thing to know, that if you're missing terms in between all of the front to back, you must write 0 of those terms in.